extra example 2, which is to convert 75 degrees and negative 15 degrees to radians, and we're going to use the addition and subtraction formulas to find their cosines and sines. So 75 degrees, we'll start out with that one. Remember, the conversion formula is pi over 180. So that simplifies down to 5 pi over 12. And that's not a common value. I don't know the cosine and sine of those of 5 pi over 12. So I'm going to write that as a combination of two angles that I do know. That's pi over 4 plus pi over 6. That's because pi over 4 is 3 pi over 12, and pi over 6 is 2 pi over 12. So you put them together and you get 5 pi over 12. The key point of that is that pi over 4 and pi over 6 are common values. I know the sines and cosines of pi over 4 and pi over 6. I've memorized them, and hopefully you've memorized them as well. So once I use my addition and subtraction formulas, I can figure out the sine and cosine of 5 pi over 12. So let me remind you of the addition and subtraction formulas we're going to be using. Here we're going to find cosine of a plus b, which is cosine a cosine b minus sine a sine b. And I'm going to go ahead and write down the formula for sine. Sine of a plus b is equal to sine a cosine b plus cosine a sine b. So let's invoke those here. We're trying to find the cosine of 5 pi over 12, which is the same as the cosine of pi over 4 plus pi over 6. And now I'm going to use the cosine addition formula. So that's cosine of pi over 4, cosine of pi over 6, minus sine of pi over 4, sine of pi over 6. And all those are common values, so I've got those all committed to memory. So this will be very quick to finish from here. This is cosine of pi over 4, I remember is square root of 2 over 2. Cosine of pi over 6, I remember is square root of 3 over 2. Minus sine of pi over 4 is root 2 over 2, and sine of pi over 6 is just 1/2. So if I put those together, the common denominator there is 4. Root 2 times root 3 is root 6, minus root 2 times 1. So that's my cosine of 5 pi over 12, which is the same as the cosine of 75 degrees. Let's find the sine now. Sine of 5 pi over 12 is equal to sine of pi over 4 plus pi over 6, which by the addition formula for sine is sine of the first one, pi over 4, cosine of the second one, pi over 6, plus cosine of the first one, times sine of the second one. And now again, those are common values. I remember them all. Sine of pi over 4 is root 2 over 2. Cosine of pi over 6, cosine of pi over 6 is root 3 over 2. Cosine of pi over 4 is also root 2 over 2. And sine of pi over 6 is just 1/2. So I put these together over a common denominator of 4, and I get root 6 plus root 2 over 4. So let's remember those two values because we're actually going to use them in the next part. The next part is to figure out negative 15 degrees. So we want to start out by converting that to radians. So negative 15 degrees, if we multiply that by our conversion factor, pi over 180, that gives us, well, 15 over 180 simplifies down to 1/12. So we get negative pi over 12 radians. Now, there's sort of two ways we could proceed from here. We could write negative pi over 12 as pi over 6 minus pi over 4. And that's because pi over 6 is 2 pi over 12. Pi over 4 is 3 pi over 12. So you subtract them, you get negative pi over 12. So we could do it that way. Or we could write negative pi over 12 as 5 pi over 12 minus pi over 2, minus 6 pi over 12. And I want to do it that way because I want to practice that. Plus, I think the sines and cosines of pi over 2 are a little bit easier to remember. So I want to practice that method. Let me write down the subtraction formulas for cosine and sine because we're going to be using those. Cosine of a minus b is cosine a, cosine b, plus sine a, sine b. And sine of a minus b, excuse me, sine of a minus b is equal to sine a cosine b minus cosine a sine b. And so I'm going to be using those subtraction formulas. The cosine of negative pi over 12, if we use the second version, that's cosine of 5 pi over 12 minus pi over 2. And now by the subtraction formula, that's cosine of 5 pi over 12 times cosine of pi over 2 plus sine of 5 pi over 12 times sine of pi over 2. Now, look at this. The cosine of pi over 2, remember that's cosine of 90 degrees, the x-coordinate of a 90-degree angle. That's 0, so that whole term drops out. Sine of pi over 2 is 1. So this whole thing simplifies down to sine of 5 pi over 12. And we worked that out on the previous page. The sine of pi over 12, we did this work before. So that was the square root of 2 plus the square root of 6 over 4. So we're kind of invoking some previous work there. This would be something that I wouldn't have remembered, but because I just worked it out in the previous problem, I remember the answer now. We're going to try to figure out the cosine, or the sine of negative pi over 12 the same way. So sine of negative pi over 12 is the same as sine of 5 pi over 12 minus pi over 2, because it's 5 pi over 12 minus 6 pi over 12. Now, using the subtraction formula for sine, that's sine of the first one, sine of 5 pi over 12, times cosine of the second one, pi over 2, minus cosine of the first one, 5 pi over 12, times sine of the second one, pi over 2. And the point of that is that the pi over 2 values are very easy. I know that the cosine, just like before, is 0, and the sine is 1. So this whole thing simplifies down to negative cosine of 5 pi over 12. And again, I worked out the cosine of 5 pi over 12 on the previous page. So the cosine of 5 pi over 12 on the previous page was root 6 minus root 2 over 4. But we want the negative of that this time. So I'll just switch those around and I'll get root 2 minus root 6 divided by 4. So the key to doing that problem, well, first of all, converting those angles to radians. That's a simple conversion factor of pi over 180. So that part was fairly easy. Once we figured out how to convert those angles to radians, it was a matter of writing them as either sums or differences using addition or subtraction of common values, pi over 6, pi over 4, pi over 3, things that you already know the sine and cosines of by heart. And so 75 degrees, 5 pi over 12, the key there was to figure out that that was pi over 4 plus pi over 6, and then know that you remember the common values, the sines and cosines of pi over 4 and pi over 6, so you can work out the sine and cosine of 5 pi over 12. The negative 15 degrees converted into negative pi over 12, and then we could write that as pi over 6 minus pi over 4. That'd be one way to do it. Or, since we already know the sines and cosines of 5 pi over 12, it's a little bit easier to write it as 5 pi over 12 minus pi over 2. Then we can use the addition and subtraction formulas, which, because of the pi over 2, essentially reduce it down to knowing the sine and cosine of 5 pi over 12, which we figured out on the previous page. So that's how you use the addition and subtraction formulas to find the values of sines and cosines at other angles when you already know the sines and cosines of the common values. So that's the end of the lecture on addition and subtraction formulas. We'll use these formulas later on to find the double and half angle formulas. That's coming next in the trigonometry lectures on educator.com.